it's like one of the best event I have, you can say, joined in my life. And regarding like its critical event details, so this is like Pakistan, one of the biggest flagship aerospace event designed to, you can say, entire aviation life cycle, from like designing of the aerospace, you can say, the architecture behind nara in the NASA aerospace engineering. As for the first time I have seen like the aerospace from starting to the end, like where it gets close up to the like to the moon. So it was like a lot to learn and a lot to explore. So that was like a full mindset shift from that event.
Absolutely, I'd say that that's a lot. And to infinity and beyond, and actually is sort of the Kennedy Space Center. And then for me, I do a lot with NGA, which is our National Geospatial Intelligence Agency. And so the motto there is from seabed to space. And that reminded me of this next slide where you're kind of the underwater. so so you got the full from seabed to space. Um, I want to actually just real quick just do. I'm just going to flip the screen for just a moment to your actual LinkedIn post, which I was so excited about. I thought you did such a great job kind of highlighting it, and I want to talk about this particular, sort of takeaways. So these are the things that you take away. So can you just talk about these and sort of summarize them a bit?
Regarding like the particular slide you have opened.
Yeah, the benchmarks are global, and actually make sure you can see what I can see. Yep, you can see what I can see. Yep. Benchmarks are global, not local. Reliability is the ultimate flex, and ecosystems create escape velocity. So yeah, I just want to chat about this for a second because I thought this was such a strong takeaway.
Yeah, although when the NASA engineer was like talking, although it was like a lot of communication, you can say 2 to 3 hours for that, but from like the starting point regarding the ultimate flex of this rocket design and a lot of, you can say, hardware, and also they have also introduced the ultimate process when the NASA engineer, you can say, a normal person, how he became the NASA engineer. So we also got to know that. So it was also exciting one. And regarding, you can say, the hardware thing and the, you can say, the complex hardware system of the whole architecture and the design, so it was like a lot of amazing to learn.
Yeah, absolutely. But I just want to say sort of these. I just want to like speak to this a little bit, where like the global, we are a global world, and so knowing
Yeah,
that those standards can be globalized, and we can all sort of be working off of the same idea of the basic the technology that we're all building on, and
yeah.
that reliability and that like you said, that precision. Uh, and I think there's both. I mean, I come out of a very creative field, and in some cases,
Hmm.
it's okay to you have to experiment and you have to try things and you have to be willing to fail. But I know that when you get into sort of these engineering sciences, there's this point that you don't want to fail. Like failure is not an option here. You have to be
Yeah,
precise, otherwise lives are at stake. People, and so to protect lives, that precision, that detail matters. Every detail matters, and every detail not just of an individual's work, but an individual, a whole team, a whole industry, a whole institution. Like everybody